So we're here at Cavium. So who are you?
Gopal Hegde. I am the Vice President and General Manager of the Data Center Processor Group for Cavium.
So what are we looking at here?
You're looking at two of our reference platforms. This one here is a one-socket ThunderX board, and this is in the ATX form factor, and this goes into a standard ATX chassis. We are developing this platform so we can make it available to all our software partners and customers for doing the development.
So what is this?
This is what a Thunder device is going to look like when we start sampling them.
So this is an ARM server chip?
This is a 64-bit, 48-core ARMv8 processor.
48 core.
Yes.
ARMv8. Do you have any GPUs?
We don't have GPUs.
So you customize for server?
So this is customized for server, and we support multiple SKUs of this part. So we have a part that basically is optimized for compute. We call it ThunderX CP. We have a part that is optimized for storage, which supports a lot of SATA interfaces. Okay, that is called ThunderX ST. We have a part that is optimized for networking with a fabric, integrated fabric, and accelerators for networking applications. We call it ThunderX NT. And finally, we have a part called ThunderX SC, which is optimized for security applications, and this integrates a number of security algorithms like SSL, deep packet inspection, IPsec, and things like that, the kind of stuff that you want in a secure data center.
So that's four different
families.
64 bits. They're all 48 core?
They're all 48, up to 48 cores.
Up to 48?
48 cores.
And they're all here or not?
So this is the one chip. We're going to have various variants of this, right? So what we are showing you here is a ThunderX processor, and we're going to have multiple families, okay, which are same pin footprint compatible.
Pin to pin? All four?
Compatible, yes.
They're all pin to pin compatible?
Yes, they are.
And these are...
These are just some reference boards. So this one is this one and this one are similar. So this is a board with the heatsink, right?
So just the heatsink on?
Yeah, just a heatsink on it.
You need the heatsink?
Well, you do, but this is a much smaller heatsink because we dissipate a lot less power compared to the competitive solutions. The other thing you notice here is that there is no other support chips. So we don't have a chipset, we don't have a PCH, we don't have a LAN on motherboard. It's all integrated into ThunderX.
So you take care of all the stuff. You take care of the LAN.
So we take care of the LAN. We take care of the PCI Express that comes out of the chip. So you see that these are the networking interfaces here, and those are the ports for that are integrated into ThunderX. So so those are your standard, standard DB9 serial interfaces, USB interfaces. That's your dedicated management port. If you want to do dedicated management, you could do management through dedicated port, or you could do it inline through the networking port.
So this is a big SoC.
This is a big SoC, yes.
This behind this is full of all that stuff in all of this.
It's inside, right? So this is a 53 by 53 package. The silicon actually sits inside.
And is this the most powerful ARM processor in the world?
This is the most powerful ARM processor in the world, yes.
For sure. Yes. Like 48 cores, 64-bit, custom designed by Cavium.
Yes.
And what's the gigahertz and all that?
It can run up to, each core can run up to 2.5 gigahertz.
2.5 times 48.
120 gigahertz of compute in one chip. And if you take two of them here like this is 240 gigahertz of compute.
240 gigahertz of compute in one board.
Yes.
That's more than anything else?
That's more than anything else in terms of any other ARM processors. We are head and shoulders above any other ARM processor.
Are you above x86 also or not?
Of course. So we basically, these processors have performance, okay, which are comparable to a high-end x86 processor.
So it's comparable with the most expensive Intel stuff.
Yes.
But
from
it's
performance standpoint, but it is lower power, much more integration, okay, and thereby delivering a lower cost and a total cost of ownership to the customer.
So it's a lower power, which is very important for cost. and it's high integration, which is also more for. How does it more from cost?
Because if you compare this board to a standard motherboard, which is designed using industry standard processors today, what you see is that you have a chipset that is required. You also have a LAN controller that is required for each of these chips. We don't need any of that. It's all integrated into this chip, so we reduce the total number of chips required to build the system.
But what are those chips?
This is our management interface, BMC. So this is required by x86 as well as us. It's a standard BMC.
What is that, like a power?
Management. It's a management for this board.
Is not the power management? Where is that?
The power management is
also
built
here
into the chip, yes.
And the other few things here?
Those are all PHYs and other stuff for connecting to the outside world. Right? This is a BMC subsystem. You need a BMC chip, you need flash memory for the BMC, and you need all the other supporting circuitry for the baseboard management controller. Okay, and then you got the networking interface here, and that requires some line drivers and such. But what is missing here is you don't need a network controller here, like what you typically have in an Intel server. Right? You don't need a separate storage controller. You don't need a chipset. That's all integrated.
That's nice. And this is the same with the
heatsink. With the heatsink.
So what do you call this? And this is the dual. This is the single, or
this is a dual. This is a single socket. This is a dual socket. This is what we call sort of a half SSI form factor. You know, this goes into this kind of a chassis here. If you look at it, this is your high density compute chassis.
So this is a standard designed for
this standard chassis, which typically takes an Intel server today, and this has 2 servers per U.
So
okay,
this
goes in here.
This goes and fills all the way there.
This goes in here, yes. And then you got hard drives in the front, and you got power supplies and everything. Okay.
Awesome. So these dual ones can also be the 4 different chips?
These dual ones, yes, it's the same. Think about, you have one instance of the chip here, and you have 2 of them here. And these are interconnected using Cavium's CCPI interface, which provides a coherent interconnect between these 2 chips.
So are those boards reference designs, right?
These are essentially reference designs that...
And your customers can do whatever they want?
Customers can do whatever they want.
So it's just to demonstrate. Is it? So it looks really nice, but does it work right now? Or is it just mock-ups?
This is a mock-up.
So how soon is it gonna work? The chip?
Q4.
Q4 is
2014. Yes.
Is what is that? That's the tape out, or is it?
No, Q4 is when the product is going to be general sampling to our customers.
General sampling and then mass production.
Mass production in 2015.
All right. So. This is not the first. It's not the only ARM processor from Cavium.
This is the ARM processor from Cavium that has been developed from scratch using the architecture license from ARM. We have had other products in our home networking that are based on ARM, but this is the one which is developed from scratch using the architecture license.
And how is it to do that? Is it an interesting experience?
It's a very interesting experience. The development has been going on for a long time. Hardware development and the software development. Cavium announced architecture license with ARM in 2012. Okay, TechCon, the development was already going on, and we showed this demo that you see here, which is the Ubuntu demo. Okay, this is Suze. Hang on a second. So this is the Ubuntu demo. Okay.
What is it running on?
This is running on our software emulator. Okay, so this is the model of the chip. Okay, that we are running, and this is basically running the entire canonical Ubuntu software.
So when the samples come out, the Ubuntu is just going to work?
It's just going to work.
What else is just going to work?
Red Hat. Fedora. This is Fedora.
All right.
Okay, and this is OpenSUSE.
OpenSUSE.
Yes.
All right. So.
And in addition to that, we have virtualization, KVM. We have Citrix Zen. All these are going to work out of the box.
Out of the box.
Yes.
And what's it called? What is this? Is that helping to run the animation?
I think this is one of graphics controllers probably. I don't know what this is.
Yeah. All right. So Cavium, is that the Cavium does networking, right?
Yes.
Is this the first server chip you do, or?
We are in data center and server platforms today with our Nitrox security coprocessor as well as Liquid I/O adapters. Nitrox security coprocessors are used to offload SSL, IPsec, all that processing in hardware. Okay, and the Liquid I/O is our SDN adapter, and it is used to provide SDN functionality, okay, as well as VNIC kind of functionality to a standard server.
But this is a different thing, right? This is like the main processor of the server.
Yes.
This is a new thing for Cavium, right?
Yes, absolutely. But we are playing with the existing servers today in the data center, and we have several customers who use our product in the data center today.
So it is your business, but
Yes.
now you are like being a bigger part of it.
We are taking it to the next level with our Thunder processor, and a lot of the capabilities that we have in those products are integrated into Thunder, and that is why we have all these personalities. You know, the ThunderX SC, for example, integrates the security coprocessing capabilities that is available in our security coprocessor today into Thunder.
So the expertise you already have, you're just using it with ARM now.
Absolutely.
And also the SDN, what is that?
Software defined networking. So this is in a product called Liquid I/O, okay, which we ship to data centers today, and they offload VNIC. It's like an intelligent virtual NIC functionality and SDN functionality that is also integrated into Thunder today. So our SoC technology, which provides core all the way up to I/O virtualization, is integrated into Thunder.
So the press announcement was yesterday.
Yes.
So all the guys, all the industry is coming here, and they must be very excited about this.
Yes, absolutely, absolutely.
And like all the cloud computing guys and all that, they really want to get their hands on the samples.
Absolutely.
And they want to start working with this.
They want to start working with it.
How big is it going to be, do you think?
The whole opportunity?
Yeah. Well, how big is the ARM server going to be? Is it going to dominate the market, or what? Or is it going to be a small part? How does it work?
You know, I think that's not. There is an opportunity for ARM servers in the scale out and the cloud, and if you look at where the servers are being deployed today, majority of the servers are starting to go into more of cloud data centers, and that's where the ARM opportunity lies. So we believe this continues to grow at a much rapid rate relative to traditional data center servers. So that's where the ARM server opportunity is. So we believe the opportunity is going to be huge, and it has a very high growth rate.
And you do 48 cores because you want to pack in as much performance as you can into it, or is that the reason?
Absolutely. We do 48 cores so we can get highest performance, and we can basically deliver compute performance and memory performance which are comparable to best-in-class processors that are out there today.
How could you do 48 cores? It's just something you can figure out how to do with because you have expertise in multi-cores from before.
Absolutely.
You did MIPS, right?
We have been doing MIPS for a long time. This is our 5th generation multi-core processor. We have had 4 generations of what we call an Octeon family, and in fact we have a Thunder equivalent part based on MIPS called Octeon 3, which is sampling to customers today. It has 48 MIPS cores. It has our CCPI interface, which allows for coherency. It has all the I/O, network I/O, which has gone into Thunder. It has a number of capabilities have actually been checked out in our existing MIPS-based platform.
So you are providing MIPS and ARM and letting the market choose what they want.
So for the server market, server market is moving to ARM, and they are very interested in ARM. A number of our customers in the embedded space also use MIPS. So we're going to provide MIPS solutions, we're going to provide ARM solutions, and we do what our customers require and meet their requirements and demands.
48 core MIPS, 48 core ARM, which one is the highest performance?
That's very hard to tell. It depends on your application and depends on your software.
Is it also 2.5 gigahertz the MIPS? Or what is
the MIPS? I don't remember the exact spec for that part off the top of my head. That's not my business group, but it's very comparable from a capability standpoint.